Hello, today we're going to start chapter 8. We're looking at 8.2 today. We're going to kind of start off, which is a little bit different than most of the time. We're going to start off with graphing for this chapter and then kind of get into solving the second half. Usually we kind of start with solving and evolve towards graphing. But this time, since you guys are all experts at graphing right now anyway, we'll get right into graphing. You're going to see same behaviors as before. We're going to have a parent function, and then we're going to make a child from the parent function. It's still going to be opposite x, same y. The behavior will be the same as it's been for just about everything else. Some issues that you guys are having overall is recognizing and identifying what the parent function is. Just make a t-chart for your parent functions. That will be the easiest form. And then after that, translate it. Today, one of the new things that we're going to be looking at, we're going to have both horizontal and vertical asymptotes on the graphs today. So both horizontal and verticals. And we will also talk about how the domain and range are restricted because of those horizontal and vertical asymptotes. Okay? So that's what we're looking at today. Parent function. These are graphs are called hyperbolas. This is really kind of what they're called. Parent function will look like that. We will have two asymptotes. This is just a sample of 1 over x. I don't expect you to put this one into your notes. Just visually make sure you're on board with the idea of a vertical asymptote and the idea of a horizontal asymptote. In this case, they're both at 0. For all the parent functions, they'll be at 0, and then we will shift them according to our translations. So the other thing that I want to take home here is realize that with the asymptotes, we have a domain and a range restriction. In this case, your domain will be all real numbers with the exception of x equaling 0, and your range is going to be all real numbers with the exception of y can't equal 0. Again, we can be anything in the world here, we just can't be equal to 0. All right. First example is a parent function. We're looking at f of x equals 2 over x. Again, all we got to do is graph it and then state the domain and range. So we'll start with a parent function. You will need 4 values for the parent functions on these. 4 values in the parent function. And for me, I'm going to tell you, let's come up. Oh, I made 5 there. Oh well. Let me get 4. 4. 4 values there. Come up with the values that you want. There's no translations or shifts on here, so it is just the parent function. We're looking at, most students will commonly start with 0. That would give you an output of 2 divided by 0. A lot of you guys can put that in your calc right now. We know that you can't take 2 and divide it by 0. That's no solution. We have a domain error. Kind of math rule number 1 is we can't divide by 0. So we will never use 0 on our parent functions for these graphs. So pick your next easiest set of numbers. In this case, I would pick 1. And then my other number is to match up the top. So that's a 2. So I'm going to pick 2. The reason is it reduces really easily. So I've got 2 over 1. So my output for y is 2. And then I've got 2 over 2. My output for y simplifies to 1. Get your positive and your negatives. If I stick a negative 1 there, that's 2 over negative 1. My output's negative 2. And I stick a negative 2, I have 2 over negative 2. My output there is negative 1. Okay, at this point, go ahead and plot your points. You have the coordinate 1, 2, and the coordinate 2, 1. We also have the coordinate negative 1, negative 2, and the coordinate negative 2, positive 1. Those 4 coordinates look really funky right now. The catch is you need to put in your asymptotes. 0, 0. The graph is much easier to sketch once you put in your asymptotes. Now you just sketch the curve going through those coordinates. Remember, your curve will always go towards the asymptotes. Domain and range, pretty easy for these guys. Anything in the world. except x cannot equal 0 in range. Y can equal anything in the world, except y can't equal 0. Okay? That's parent functions. Kind of pretty easy on this stuff. I have a hunch that you guys will kind of find that today's graphs are, I think, even easier than the logs and the exponents. All right. Checkpoint. You guys, go ahead and pause that video. Get this graph down. I'll give you a little tip before you get started on your parent function here, because this is the graph of a parent function. Use the starter values of 3, 1, -1, -3. Again, 3, 1, -1, -3. Look carefully at this, y equals 3 over x, and figure out why I'm telling you to use those starter values. Contrasting on this one, where I told you to use the starter values of 1, 2, -1, -2. Okay? Pause the video. When you're done with that checkpoint, we'll go ahead and move forward. Okay. Hopefully you're done with that checkpoint. Here we go to the next example. This one, we're looking at f of x equals 1 over x minus 3 plus 2. Again, f of x equals 1 over x minus 3 plus 2. I'll give you a second to copy that down. Hopefully, as you're looking at this and getting it copied down, you're thinking to yourself, self, because that's what you call yourself. This is going to be kind of just exactly what we did before, but I notice that this time I have a change in my x values and I have a change in my y values. In fact, it's probably going to be opposite x and the same y. Oh me, oh my. It's almost as if we've been talking about that, I don't know, all year long. Yes, that is indeed what's going to happen on this problem. So, again, we're going to have shifts of +3 for the x and shifts of 2 for the y values. And let's go ahead and get our parent and then make a child. Parent function's a little harder on this one. We're looking at f of x equals 1 over x this time. In the past, I told you to match that up. In this case, it's a little bit harder to match up. I'll just use the number 2. Using number 1, if I input 1, my output's 1. If I use the number 2, my output will be 1/2. If I input -1, my output's -1. And if I input -2, my output's -1/2. Child on this one. Opposite x, same y. So that will be +3 for every change in x and +2 for every change in y. So we'll just go ahead. 1 plus 3 is 4. 2 plus 3 is 5. -1 plus 3 is +2. And -2 plus 3 is +1. My changes for my y values now, I'm adding 2. 1 plus 2 is 3. 1/2 plus 2 is 2 and 1/2. -1 plus 2 is 1. -1/2 plus 2 is +1 and 1/2. I visualize that as 2 minus 1/2. 2 pies, and you eat half a pie, you have 1.5 pies left. So my red is my function that I'm trying to graph. So we'll go ahead and plot those points. First coordinate is 4, 3. Next coordinate is 5 and then 2.5. 5 and then 2.5. Next coordinate is 2, 1. 2, 1. And the next coordinate is 1, 1 and 1/2. 1, 1 and 1/2. Once again, we have 4 coordinates that look awkward when we're trying to graph them. We need to cover our asymptotes with this. So remember that your asymptotes are dictated by the change in x and the change in y. In this case, our x asymptote, X will not ever be allowed to equal 3, and that should make sense to you. X can never equal 3 here. The reason X can never equal 3 is because 3 minus 3 gives us 0 in that denominator. So X can never equal 3. 3 right there. I put that vertical asymptote at X equals 3 because X can never equal 3. And if X can never equal 3, that means Y can never equal 2. And again, notice that positive 2 is our horizontal Y asymptote, and positive 3, which is opposite X, is our vertical X asymptote. After you got your asymptotes in, you can see how this graph is going to behave. Draw your curves towards the asymptotes. Draw your curves towards the asymptotes. Last part, play doctor, that's domain and range. Your domain and range restrictions are given to you in the context of the problem. X can equal anything in the world, but X cannot equal positive 3. Y can equal anything in the world, except Y cannot equal positive 2. There's your domain and range. It should match with what you see with the asymptotes. Really a lot of critical thinking on these problems. The graphing themselves aren't hard. I hope at this point of the game you're starting to get a mental picture of what's happening graphically before you even set up and do the dirty work. All right. I think you guys got another checkpoint coming. There you go. Go ahead and pause the video. I was nice and gave you an easier function than the one I just gave you. There shouldn't be any fractions in here if you do your work right. So go ahead and pause the video. Get that bad boy graphed. Unpause it when you're ready to move to the next one. All right. Hopefully you got that thing graphed. And we're moving on. This is the last example. We're looking at y equals negative 6 over x plus 3 plus 2. Again, parent, child. You should see what we're doing with the parent function on this one. We're going to have a change of negative 3 for our x values and a change of 2 for our y values. Parent, child. Before I give you guys an example of how to do this problem, I would challenge you right now to answer this question to yourselves. How is this graph going to be different than all the other graphs we've done today? Again, how is this graph going to be different than all the other graphs we've done today? And while you guys are thinking about that, today's drop-in magical word is going to be, I don't know. We'll make it Disneyland. Today's magical word is Disneyland. All right, back at the problem. Let's make a parent function. Oh, and I'll tell you the answer about how this graph is going to differ when we graph it, and I'll talk about it. So, we've got parent function, hopefully you said, is y equals negative 6 over x. That's parent function, so pick easy values. 1, 6, negative 1, negative 6. You should know why I picked negative 6 and positive 6 for this. Plugging in. Negative 6 divided by 1 is negative 6. Negative 6 divided by 6 is negative 1. Negative 6 divided by negative 1 is positive 6. And lastly, negative 6 divided by negative 6 is positive 1. By the way, most common mistakes on these problems are with the positive and negatives, not with the Algebra 2. Time to make a child. By subtracting 3 for all of our x values and adding 2 for all of our y values. 1 minus 3, negative 2. 6 minus 3 is 3. Negative 1 minus 3, negative 4. Negative 6 minus 3 is negative 9. Your y change, adding 2. Negative 6 plus 2 is negative 4. Negative 1 plus 2 is 1. 6 plus 2 is 8. 1 plus 2 is 3. So there's the graph we're going to make. Let's see, I don't like the scale on this graph, so I'm going to get a different graph up there. We'll do that one. There we go. Okay, let's go ahead and plot these coordinates. -2, -4, +3, +1, -4, +8, and -9, +3. Again, we've got 4 coordinates. They look funky. Do not try to connect the dots until after you've covered your asymptotes. And again, your asymptotes, if you're making a parent-child, they're telling you right here where your asymptotes are. 1, your x-asymptote is at -3. Your x-asymptote is at -3. And your y-asymptote is at +2. There we go. We've got our asymptotes. Now it should make sense as to where we're going to draw these curves. Connect the dots going towards the asymptotes. Domain and range here. Play doctor. And x can be anything in the world except for x cannot equal -3. And range y can equal anything in the world except y is not allowed to equal +2. Domain and range connect to the graph. Again, looking at this graph, I asked you the question at the very beginning, how is this graph perhaps going to be different than all the other graphs we graphed? If you said to yourself, all our other graphs were in quadrant 1 and quadrant 3, this time they're reversed because they're going to be quadrant 2 and quadrant 4. And I think they're going to be reversed because we had a negative up there. Indeed, that's what's going to happen. So reach around, give yourself a little pat on the back, say good job, and then get your last question right, which is your last checkpoint. All right, there's your last checkpoint. You should know the parent, you should know the child. You should actually have a mental picture of what that graph's going to look like before you even start it. And you should know your domain and range right now before you even start it. Okay? Good luck. That's it for the video, and I'll see you guys in class tomorrow.